What if everything you understand about reality simply stopped working? Not in a way you could predict, but all at once, because somewhere in the universe, there are places where the rules completely break. We call them black holes. Let's start with something simple: gravity. Every object with mass attracts other objects. The more mass something has, the stronger its gravitational pull. On Earth, gravity is what keeps us on the ground. It keeps the moon orbiting our planet and the planets orbiting the sun. But gravity is not the same everywhere. In some regions of space, it becomes far more powerful than anything we experience on Earth. Now consider a massive star. A star shines because of nuclear fusion happening in its core. This process releases energy, creating an outward pressure that balances gravity. For most of a star's life, these two forces are in equilibrium. But eventually, the star runs out of fuel. That time, the outward pressure drops, and gravity begins to dominate. The star starts to collapse inward. If the star is not very massive, it may become a white dwarf or a neutron star. But if the star is large enough, the collapse continues without stopping. The core is compressed into an incredibly small space. Density increases dramatically, gravity becomes stronger, and eventually, a black hole is formed. A black hole is not a hole in the traditional sense. It is a region of space where matter has been compressed to such an extent that its gravitational pull becomes extreme. One important thing to understand is that black holes still follow the same basic laws of gravity. For example, if the Sun were replaced by a black hole of equal mass, the Earth would continue orbiting in the same way. The gravitational effect at that distance would not change. Even though black holes themselves are invisible, their surroundings can be extremely bright. Matter falling toward a black hole often forms a rotating disk, known as an accretion disk. This material moves at very high speeds and experiences intense friction. As a result, it heats up and emits large amounts of energy, including visible light and X-rays. This glowing disk is one of the main ways scientists detect black holes. Another important feature of a black hole is the event horizon. The event horizon is the boundary that surrounds the black hole. It is not a physical surface, but a point of no return. Once anything crosses this boundary, it cannot escape the gravitational pull of the black hole. To escape, it would need to travel faster than the speed of light, which is not possible according to our current understanding of physics. As we move closer to a black hole, its effects become more noticeable. One of the most interesting effects is the bending of light. Because gravity is so strong, it can change the path that light takes. This phenomenon is known as gravitational lensing. Light from stars behind the black hole gets curved, causing those stars to appear distorted or stretched. In some cases, this creates ring-like structures of light around the black hole. Black holes also have a strong effect on time. According to Einstein's theory of relativity, time is not constant everywhere. In stronger gravitational fields, time passes more slowly. Near a black hole, this effect becomes extreme. To an outside observer, an object falling toward a black hole appears to slow down as it approaches the event horizon. Eventually, it seems to stop completely. But from the perspective of the falling object, time feels normal. It continues moving inward without noticing this slowdown. As the object moves even closer, it experiences something called tidal forces. These forces occur because gravity is stronger closer to the black hole and weaker farther away. This difference creates a stretching effect. The side of the object closer to the black hole is pulled more strongly than the side farther away. Over time, this causes the object to stretch into a long, thin shape. This process is known as spaghettification. Despite everything we know about black holes, what happens inside them remains one of the biggest mysteries in science. According to current theories, anything that crosses the event horizon is pulled toward the center. At the center lies the singularity. This is a point where density becomes extremely high and the known laws of physics break down. We do not yet have a complete theory that can describe what happens at the singularity. Consider for subscribe. See you in the next video.